Welcome to BTEC Revision. In today's lesson, we're looking at EM induction and eddy currents. By the end, we should be able to calculate the EMF induced by Faraday's law and describe eddy current. How can you generate an EMF from a conductor? An EMF is induced or generated in a conductor when a magnetic flux is cut. For example, if we take a coil and pass a magnet through it, an EMF will be induced in the coil, and vice versa. What are the rules regarding electromagnetic induction? We have Faraday's law, which states that when a magnetic flux is changing, an EMF is induced, which is proportional to the rate of change of flux. How can you calculate the EMF induced from a conductor? We can use the following equation. The induced EMF is equal to negative number of coils times the change in flux divided by the change in time. And the short form is epsilon equals minus n times delta phi divided by delta t. And the units are for phi, v Webers, time is measured in seconds, number of coils has no unit, and EMF has the unit of voltage. Now let's look at an example. A coil with 500 turns and a cross-sectional area of 0.002 meters squared is placed in a magnetic field. The magnetic flux through the coil changes from 0.005 Tesla meters squared to 0.015 Tesla meters squared in 2 seconds. Calculate the induced electromotive force in the coil. We can start by writing down our equation. EMF equals minus n delta phi divided by delta t. Plugging in our values, we have minus n is 500, and the change in flux would be 0.015 take away 0.005 and divided by change in time, which is 2 take away 0, so that's just 2. And this gives us a value of minus 5 over 2, which is equal to minus 2.5 volts. We can also use this second equation. The induced EMF equals the magnetic flux density times the length times the velocity. And the short form is epsilon equals BLV. Velocity is measured in meters per second. Length is measured in meters. Magnetic flux density is measured in Teslas. And EMF is measured in volts. Now, let's look at the second example. A conducting rod of length 0.2 meters moves perpendicular to a magnetic field with a velocity of 3 meters per second. The magnetic field strength is 0.5 Teslas. Calculate the electromotive force. We can start by writing down our equation. EMF equals BLV. We know B is 0.5, length is 0.2, velocity is 3, and working out these values gives us an answer of 0.3 volts. Now pause the video here and attempt this exam question. You can start by writing down our equation. EMF equals minus n change in flux divided by change in time. And we can rearrange this for flux or change in flux, so that will give us EMF delta t equals minus n delta phi. We can divide by minus n to give us delta phi equals minus epsilon delta t divided by n. Now we can plug in our values. Minus 2.5 times 0.4 divided by 250. And that gives us a value of minus 4 times 10 to the power of minus 3. And the unit is Webers. And that's the end of the lesson. If you'd like to boost your grades, visit us at btechrevision.com. See you next lesson.